Hey guys, welcome back to our channel. Today we're gonna discuss about the characteristics of software. I'm gonna compare the characteristics of software with the hardware. So totally, I've named this video as software versus hardware, and this video is brought to you by Future. In this event, we will take a tour at the what are the characteristics of software and how they are competed with the characteristics of hardware. How they are they efficient more than a hardware. We're gonna discuss all the things in this video, so don't skip it. That's the only request from my side. Okay, first we will take a tour on all the characteristics. What are the characteristics of software? Then I'll explain you all in-depth details in the next slides. Okay, as a first software characteristic is software is manufactured. Remember this point, you have to note it, because software is not manufactured, it is always developed. Okay, it is not gonna be manufactured like a hardware. Okay, and one more characteristic is software shouldn't wear out. I'll explain in the next slide, because this has to be explained with some examples, then you will be getting a clear idea. And the software is mostly custom built rather than being assembled. Okay, first characteristic is my software is developed, right? As software is developed, and so most hardwares are manufactured. I can see that what is mean by manufactured, right? What is developed? What is the difference between developed and manufactured? Manufacturing is that how to say that preparing one thing and replicating again and again and again and again. Okay, you will be designing one thing and you will be replicating it other times. Like we have designed one chip, and you have completely taken out with the one chip, and for commercial use you will be replicating it again and again and again and again. So by replicating this process, replicating this original chip to many other chips, then there is a decrement in the quality. Definitely you'll be getting a lapse in quality. So the hardwares doesn't compete with the hardwares. Okay, because software qualities are higher because they are developed. Okay, each software is different from each other, so they have to be developed, not manufactured. Only these things you have to remember. Hardware is replicated again and again, but the software is always unique. It has to be developed, not replicated. If you replicate it, it's not gonna work out in any prospect in the software engineering. And hardware, as I've discussed about, because you're gonna manufacture it, your software is gonna be manufactured, so it is gonna have less quality automatically. And next characteristics of software is a software shouldn't wear out. That means software shouldn't diminish for a long distance. Okay, it has to withstand with all the conditions which the society is going to be applied on it. So it has to stay strong against all the conditions, unfavoring conditions. As you can see that a graph can be visible. This is hardware graph, not software. Let us divide this graph into three phases. I'll explain through the phases. This is the first graph, and the graph looks like the bathtub, right? And this is the second graph, and this is the third phase. Okay, this is the first phase, and this is the second phase, and this is the third phase. Okay, remember those phases, because I'm gonna explain through these phases. As the first phase, you can see that there is a high failure rate at the install time only. Okay, I have plotted a failure rate on y-axis and time on x-axis. Okay, as initially preparing the hardware, you will get many replicated, many defects in it. Okay, whether it's quality wise, whether it is a lifetime wise, because you will be having a very high failure rate at initially when it is designed. And whenever you have identified those defects in the hardware, and you'll be correcting it, right, then the failure rate comes down like this. Okay, to which reaches to phase 2. Then you have corrected all the defects, and this is the phase 2. You have corrected all the defects. Okay, so it is parallel to x-axis. Okay, and you may think that why again the failure rate has increased, right? Yeah, there's a reason for that. So due to some environmental conditions like smog, dust, all of these due to these unfavorable conditions to the hardware, it gets again failure, and it may look like this, not actually like this. Okay, don't worry about that. Okay, failure rate again increases because of environmental conditions, whether it might be dust, smoke, fog, whatever it might be. But in the long run, the hardware will be damaged due to environmental conditions. And there's another graph because we have to discuss about software too, right? As a software, I will be dividing into two graphs. This one, okay. Let's take a pen, and these are black, bright black. This is the first graph. Take this as a first graph, a black. Yeah, this is the one which I am talking about. A bright graph line which look like a idealized graph. Take a look at on it at the starting initial, and remaining part of the graph I will discuss it. Okay, software is not affected by environmental conditions because it is gonna saved in a computer, so it is not gonna affected by environmental conditions directly. Okay, it gets a protection from several environmental conditions, which have to be packed. Okay, so environmental conditions are not gonna show any effect on software, so I have drawn this idealized graph which is in the dark black. Okay, dark black. And as you can see, some another type of graph which looks like idealized graph, but it has got some spikes. Spikes are called like this. Okay, these are spikes. As you can see, many spikes will be there. You may have question why we have got those many spikes. Every time the spike is gone up, the failure rate goes up. Okay, hope you're getting my point. Each and every time the spike goes up, as in that, so you can see that every circle is which I have circled, every part of the graph is a highest peak of the spike. There the high failure rate is so high. Okay, why you may ask why this is happening continuously, right? I'll explain it, don't worry. This is the one. For every change in a software, okay, so if once you have identified the software, of course when it is made it will be containing internal defects in it, internal bugs in it, whatever it might be, you will be having a high failure rate as the same as the hardware. Okay, once you have been correcting it, and the failure rate comes down, and once it is comes down, and softwares are not the one which you have to make it idealized one. So the customers will be asking you for the new updates, new features in it. So you have to make a new updates in the you have to add new features, we have to add new updates. So every time you make a update in it, the failure rate again goes up. So this is the one which I am talking about. The spikes goes up at that position. Every time you make a update, it goes up. Okay, and once that bugs have been identified and they have been corrected, so the spike comes down, comes down, slowly comes down. It comes down like this, like this. Again, when you make an update, it goes up, right? Again, when you go up, it goes up. Again, you will be correcting it, and will be so. Software is not a one. Once you have created, just you can't leave it, because customers will be asking for your new updates. Every time you make an update, you'll be getting this. You have to correct them. Of course, the bugs are very usual thing in the software industry. You have to correct them. That's the biggest thing. Okay, hope you're getting my point. These conditions which I've talked about wear out. So software is not a one which is gonna wear out at a long instinct, but it gets worse. Okay, if you leave it, it's gonna worse it. Okay, because if you don't make any updates, if you don't make any corrections in the bugs, definitely the software has to fail. It's gonna not affect any market there. You won't impact the market. And the next one is a software is custom built. Both hardware and software are custom built, because we have seen many hardware industries will be using reusable components to make a new one, right? As a software, making a good steps forward it to making some reusable softwares. Once the software has been used, it has to be reused. Many steps we have been taking. I'll say one example in it. As you came across at least one programming language, every programming language contains functions, right? What's the biggest advantage of functions? Reusability, right? That's where the software industry has changed. Okay. So, okay, what is the use of these reusable components, right? It encourages innovation. How can I say that encourages innovations, right? Of course, I will be explaining it. Once the software has been developed, and again it has been reused. Okay, if someone wants to make an update on it, okay, once you have got reusability, you can just initialize it in your system, and you can make updates. So it makes you a task very easily. You can make updates. If you don't use reusability, again you have to type all the codes, you have to debug, you have to remove all the bugs. That makes so complicated. So if you have reusable components in the software, then the software is a more mature project. So you can just reuse those software and make a new update. It is gonna definitely innovate, encourages innovations. So that's why software are being taking new steps forward innovations, and as field has been growing day by day. Thank you for watching, guys. These are characteristics of the software I've compared with the hardwares. Hope you have got a clear observation on this topic. And the next one I'll be coming up with the frameworks. This is very important in the software engineering frameworks. So I'll be coming with that video. Stay tuned, guys. Don't forget to like this video if you liked it, and if you're new to this channel, subscribe to my channel and click on that bell icon. Thanks for watching. Take care. See you in the next video.